Hey guys, I hope you guys are doing good today and welcome to the today's video. So on today's video, we are going to talk about specifically on chaos engineering and Kubernetes control plane. So there are 10 chaos faults which is mandatorily you required to inject on your Kubernetes control plane. So Kubernetes control plane is one of the most important component or layer because like lot of pod scheduling, pod management, controlling, persistent volume control, entire infrastructure will be get controlled over through this Kubernetes control plane. So control plane is very important, and if it is gone or someone come and screw it, like there should be something kind of a disaster recovery. There should be a kind of some fix and automation and some config management tool push has to be there. So this is all about something called the like chaos engineering faults. So basically like we break the system and then only we understand like what exactly happening on the Kubernetes control plane. So there are 10 faults that I have curated for you. I request you to watch this complete video entirely without missing anything. The entire video will give you a clean idea about how to manage the Kubernetes. Okay, so without wasting any time, just get into the video. The first one which we're going to talk about, HCD. So HCD, it's one of the key value store database on Kubernetes. It stores entire object information over there. So if HCD is down, and the impact will be a very badly actually. Okay, so what happened if HCD data corruption? So data stored in the HCD database become corrupted and due to a software bug or hardware failure. Okay, you injecting a fault, something, a bug on HCD database. If it gets got corrupted, what's an impact? Then you know, right, impact is completely it will be down, and Kubernetes API control plane can't access the HCD, and pod scheduling, pod management, everything will get failed. So use a backup and restore process to recover the HCD data. Okay, so always you should be having installing an HCD in a high availability mode. It should have 2 or 3 replica in different servers or different region, and specifically it should have some quorum to be maintained, and use monitoring tool to identify and resolve the root cause of the corruption. Okay, and you have to have a proper monitoring. If something is not in healthy, then you have to go ahead and address it. So this is all about an HCD data corruption. Okay, API server down. So API server is actually an heart of Kubernetes. If API server is down, then it is very hard to communicate to HCD, scheduler, controller, kubelet, and kube proxy, and everything will get screwed, and you cannot do anything. So the impact will be a very high actually. So what's happening? Like, so consider API server becomes unavailable due to a network and hardware issue. So what will be an the fix to overcome it? So we have to use a high availability setup with multiple API server and load balancers, and configure the Kubernetes component to retry a request in case of API server is unavailability. So sometimes there will be a network glitch. API server may cannot ping it for 2 seconds or 3 seconds. The other time it should not come up with the timeout. It should be having something a retry option, and all those things has to get it configured. Okay, kubelet failure. Kubelet is known and one of the important component in Kubernetes plane. So API server, basically kubelet runs on nodes, not worker nodes, basically not on the Kubernetes control plane node, master node. So it will be a communication between the master node and the worker node. So kubelet failure, what will be an impact? So basically, like, Kubelet is an agent running on the Kubernetes node. It fails due to a bug or configuration issue. So sometimes someone will be killed that process. Someone would have been corrupted. Or a lot of things may happen, right? So what's the thing that you have to do to overcome? So you have to place an health check mechanism to monitor the kubelet status and automatically recover and replace the failed nodes. So that's the matter actually. Like, okay, there should be a proper monitoring. There should be a proper API call and identify the resolved root case of kubelet failure using a monitoring and logging tool. This is very common, right? You have to place an automation whenever the server get rebooted. It should have to come up automatically. If kubelet is down, automatically have to come up. So these kind of watchdog kind of stuffs that you have to in place in your server. Scheduler unavailability. Okay, the scheduler becomes an unavailable and preventing a new pods of being scheduled. Okay, so this is everyone knows. Schedulers will usually schedules the pod. So around of 10 nodes that we have, our worker nodes. So the which pod has to go on which node. So it will check on some kind of criteria, basically like how much of CPU has, how much of memory has, whether this pod will fit on the particular node or not. So this will be the scheduler job. Okay, so if that is completely unavailable, so the impact will be similar. Pod scheduling may fail. So what is an thing that you have to do? Use a high unavailability setup with multiple schedulers instance, and then like configure Kubernetes component to retry a scheduling request in case of scheduler is unavailability. So that's all, guys. Okay, let's move on to the cluster DNS failure. So, what's a cluster DNS actually? So, basically, like DNS is one of the important factor in Kubernetes, where they use core DNS, kube DNS, a lot of things. I believe the people are using, I guess, the kube DNS. So, DNS services become unavailable. Basically, the service discovery failure. Say, for example, like we have one pod, it connects to the database, and database name has been added into our DNS, the core DNS config map. Say for example, DNS is a one. If particular DNS is down, then that a prod cannot get communicated. It cannot resolve that particular service, and it cannot route the request to the DB server. So that's the problem, guys. I hope you may understand. So DNS server is completely down. What should be an issue? This is an issue. So it cannot resolve and it cannot route the request. So use a health check mechanism to monitor the DNS service and automatically and recover and replace the failed DNS component. Ensure DNS service is properly configured and resolvable from all nodes. So basically, guys, this core DNS or kube DNS, it runs on a pod on the Kubernetes. That I think the public, not public namespace, Kubernetes internal namespace. I don't remember the name, forget it. So basically, like you it runs on the pod. If that pod got corrupted, it pod got crashed, it should have to be come up automatically. There should be a proper replica has to be in place, and those things that has to be maintained in high availability, and it has to have a proper the monitoring mechanism should be there. So SRE team should be monitoring this particular pod because it's so critical. Okay, node label and taint issues. So basically, like node labels that may define the nodes, the labels. Basically, like this pod has to go on server one and server two, and this pod has to go on server three and server four. Basically, like you can define the labels depending upon your the what you can say, like your functionality of your applications. So taint is also the similar things. Actually, taint is basically like if this server I should not schedule it. I should not consider to schedule it, but something like this pod has to run it on different space. For example, like we have app space, app pod, and we have a DB pod. DB pod should has to schedule on server 567, and the app pod should schedule on server 123. And by default, without any issue that due to some issue, by DB pod should not go on one or two or three. So these kind of things that you can taint it basically. Basically, like this is the one of the feature in advanced Kubernetes scheduling space. So the Kubernetes node may become incorrect actually. So the taints or labels of Kubernetes node become incorrect, the cause of pod to be scheduling improperly. So that is what if it has been removed or someone have deleted something on the labels, so it will be a problem, right? It won't schedule it on the right nodes. How you can manage? So config management tools to manage the labels and taints of the Kubernetes node. Use node affinity rules to ensure that the pod are scheduled on the correct nodes. Okay, there is a rule I believe in a Kubernetes advanced scheduling mechanisms that you can define its required scheduling or mandatory scheduling. Those things are there. API authentication failure. So API authentication failure, what it talks about, like API server, it's an heart actually. Basically, it communicates with Kubernetes worker node, controller, scheduler, HCD, and all those things, right? So API server authentication mechanism it fails and preventing an user from accessing an API. So there is an the token or user will be used to authenticate. To access that particular API or to access that particular object, they use certain mechanism inside in Kubernetes there. I will talk about this in specifically on the next video. And if that authentication is completely failed, there will be an issue. Like you cannot deploy a pod or you cannot access a pod, basically like cannot delete it, or basically like you cannot make a change on the deployment spec, and all those things will be there, right? So you have to use a high availability setup for multiple authentication providers. The configure Kubernetes component to retry an authentication request in case of authentication provider is completely unavailable. What it talks about it, like it connects with LDAP, SSO, or all those things. So API token, if token got expired, the certificate validity got expired, there'll be an issues, right? So those things it talks about. Okay, controller manager failure. So controller, it's also an important component in the Kubernetes. If the controller manage becomes unavailable, it prevents the cluster from reconciling it to desired state. So basically, it keeps the states whether this pod it has to be in running. Okay, if it is down, the controller will come and it will kick off the replica. It will restart it. So this is the importance of the Kubernetes controller. We have to use a high availability setup with multiple controller manager instance. You have to configure the Kubernetes component with retry controller request in case of controller is becoming unavailability. That's all, guys. So you have to place an high availability. Each controller should runs on different availability zones. At least we have to have a 3 controllers in your cluster. Network plugin, this is down, then entire environment is down. So what I mean to say is, like, network plugin, it helps to use for communication between the nodes and communication between the pods. There is a lot of CNI plugins are available in the market. If you use that particular plugin, you have to make sure that that CNI plugin pod has to be up and running. Say for example, you are using Calico or ViewNet, these pods should has to be up and running. If something that's down, an entire communication will fail. The pod cannot communicate with another pod. Then there will be a lot of latency issues will create, lag will be get created, will be an issue. So to overcome this, you have to have a health check mechanism, and you have to make sure that pods are running, the View network pods are running, and use to monitor the network plugin automatically recover, replace the failed component. That's what I've told you. There should be a replica has to be there, and ensure the network plugin is properly configured and compatible with Kubernetes version. Persistent volume claim. Okay, PV or PVC. This is an CNI. Sorry, the network plugin is the CNI, containerized network interface, and containerized storage interface. We say CSI. So this is also an very important. If the persistent volume is someone deleted, the claim has been reached like 100%, it completely used, and then like the if you use a storage class or using your persistent volume in AWS EBS volume, if there is an issue with the AWS EBS volume, then also it's an impact. So basically, like, if it is not attached to the pod, it prevents the pod from accessing a required data. So basically, like, you cannot access the data. Mostly it happens on the database. The database, they need a persistent data. So data that comes with along with the persistent volume. If the persistent volume is not bound along with your pod, then definitely there will be an issue with the data durability and consistency. We have to use the proper mechanism to detect the persistent volume, um, the claims failure, and automatically provision, attach a new volume, and all those things. We have to have a proper monitoring and ensure that the storage backend is properly configured. And then that's what told you that the storage class, if you are using a storage class as AWS, you have to make sure your EBS volume should be on what kind of type. If it is a GP3 or GP4, all those things that it's matter, right? And you have to check about your credit burst balance if it got completely breached, and that's also an issue. You have to make sure enough capacity to handle the complete persistent volume claim. So these things, guys, it's all about that Kubernetes control plane chaos. If someone injects or someone will manually go ahead and screw it, you have to make sure to restore that service within some times, actually. Okay, that's all I have. I hope you might have enjoyed this particular video. We'll see you on another good video. Thank you so much. Please do subscribing it, like it, hit the like button. Thank you so much. Bye bye.